Hi everyone, this is Mrs. G.A. and today we're going to learn about the inverses of simple quadratic and cubic functions. Before we do that, I have a quick warm-up for you guys, so please find the inverse of these three functions. Alright, so go ahead and check your work. So remember, the basic steps for finding an inverse of a function are to swap the location of x and y, and then you simply solve for y. And then this notation, this f, it looks like it says to the power of -1 of x. This is our notation for our inverse. So we read it f inverse of x. So here's the first one. For the second one, you can write your answer in two different ways. You can either say x plus 7 all divided by 2, or you could actually divide the individual terms by 2 and have it look like this. And then for part C, you should get f inverse of x equals 3x minus 8. So we're going to be using that same process today with our quadratic and cubic functions. Alright, so let's start by looking at the inverses of quadratic functions. So you can see here in red we have a graph of y equals x squared, our parent function for quadratics. So you can see that if we take this and we swap all of the x and y values, which is what we're doing with an inverse, we get this graph in green. So the issue that we have with this is if you look at the green graph, it is actually not a function. And the reason why it fails that vertical line test. Remember, you draw a vertical line, and if your graph crosses that line more than once, it is not a function because for this given x value, there are two y values. So that means that for these types of functions, for our quadratics, one way to assure that the inverse will also be a function is to limit the domain of our original function. So we are going to need to do that because we would like both our original function and our inverse to be functions as well. Okay, so we are going to be, like it says here, we're going to restrict the domain. So here's how we can do this. Again, we're going to be following those same steps of swapping x and y and then solving for y. The inverse of a quadratic function is going to be a square root function. So we are going to need to take the square root to help us solve. However, we're going to need to do this extra step, again, of restricting the domain. So to do this, we're going to find the x value of the vertex, and then we're going to restrict the domain to only the values to the left or right. So if I look back over to this graph, we would say, okay, we're only going to use this portion of the graph, right? Or maybe we only use the left portion of the graph, but we're really only going to be using half of our graph. And then if we find that if we do the inverse, the result should also be a function. So again, we do need to restrict the domain using these two steps. All right, let's give some of these a try. So this says to restrict the domain of each quadratic function and then find its inverse, and then we can check to make sure our answer is correct by graphing. And you can use Desmos to help you graph if you would like. So here we have f of x equals 1/2 x squared. So we know that for a graph like this, the vertex is at the origin. So the vertex is 0, 0. So we're going to actually be restricting the domain to either everything to the right of that or to the left of that. And I'm usually going to pick everything to the right. So now we're going to list what our domain is. So our domain is going to be everything, let's pick everything to the right of our vertex. So the x value of our vertex is 0. So it's everything from 0 to positive infinity. Okay, so now we've restricted our domain. Once you have that domain restriction listed, you can just find the vertex, or you can just find the inverse just like we did in the warm-up. So we're going to swap x and y. So we say x equals 1/2 y squared, and now we need to solve for y. So we can multiply both sides by 2. And then the way we clear a square is by taking the square root of both sides. Usually we would take the plus or minus square root of both sides, but in this case, we're just going to have the positive square root of both sides. So we end up with square root of 2x equals y. Okay, and then we can even write it with our proper notation, f inverse of x equals the square root of 2x. Okay, so there's our inverse. So let's check, let's see what these graphs would look like. So if I graph this first function, we get something that looks like this. So notice it is a parabola, but again, we've restricted the domain to everything 0 and to the right. So I'm only graphing that half of our function. And now we can graph our inverse function, and we actually get a graph that looks like this in red. So you can see that this, the blue and the red graph are in fact reflected over this line y equals x. Here's that line y equals x, which is one way we could check to see if our answer is correct. So we can see here that since our graph is reflected over that line, our inverse must be correct. And you can see that our inverse is also a function. So by restricting the domain, we were able to create an inverse that's a function. All right, now let's look at part B. So for part B, let's start by finding the vertex. So the vertex of this graph was at 0, 5. Hopefully you remember how to find the vertex of a quadratic. If not, make sure you go back and review that from previous chapters. So again, we're going to restrict our domain to either to the right of 0 or to the left of 0. So let's pick to the right of 0 again. So again, our restricted domain is going to be everything 0 to infinity. Okay, so when we graph it, we start at 0, -5, and we're only going to be graphing points to the right. So it looks like this, roughly. And now we can go through the process of finding our inverse. So again, we're going to swap x and y. So we got x equals y squared minus 5, and now we solve for y. So we add 5 to each side, and then we are going to take the square root of both sides. So the square root of the entire thing, x plus 5, equals y. So our inverse would be f inverse of x equals the square root of x plus 5. So if we graph this really quick, we end up with a graph that looks like this in red. So you can see again, by doing this, we can check to see that it is reflected over that line y equals x, which it is. So again, by restricting the domain, which we did here, you can see that our resulting inverse is still a function. Okay, let's look at example C. So for example C, again, we're going to start by finding the vertex. So in this case, our vertex is at -2, 0. So you can see that our x value has actually shifted. So again, our vertex would be here. So we're going to restrict this parabola to, again, let's do everything to the right. So here's our domain restriction. Everything to the right of our vertex. So that would be everything from -2 to positive infinity. And then we could graph that like this. There you go. So we have our half of a parabola. And now we can find the inverse. So again, swap x and y. X equals y plus 2 squared. So in this case, that plus 2 is trapped inside our parentheses, so we actually have to clear the square first. So we're going to take the square root of both sides first, and then we can subtract 2. But notice that -2 is going to be outside of our square root. And then this is our inverse. And so let's graph it really quick to double check. And we end up getting this graph that you see in red. So again, it is reflected over that line, y equals x. So we know that our inverse is correct. And again, thanks to that domain restriction, the inverse we found is also a function. All right, so at this point, I'm going to ask you to pause the video and then go ahead and restrict your domain and then find the inverse. And then we will check your answer in just a few seconds. All right, so go ahead and check. So you can see here, since our vertex is at 3, 2, I restricted my domain to everything 3 to positive infinity, so everything to the right of our vertex. Then here we can swap x and y and solve for y. Here, make sure you subtract 2 first, but then you need to take the square root of both sides before you add 3, because this minus 3 is trapped inside the parentheses. And then notice when I add 3 to both sides, this plus 3 is not part of the square root. So this is our inverse function. And then just to check, I kind of graphed it over here. The blue is our original function, and then the red is our inverse. So you can see that it is reflected over that line, y equals x. So we know our answer is correct. Okay, so now we're going to move on to the inverse of cubic functions. Okay, so the inverse of a cubic function, which is a function with x cubed, is going to be the cube root function. So just like with x squared, it was a square root. Here with x cubed, it's going to be a cube root. Now for this, luckily, we do not need to restrict the domain because its inverse is already a function. So we don't need to worry about that extra step like we did with quadratics. So here's what these graphs look like. So the parent function for a cubic function looks like this. It kind of looks like half a parabola here, and then the other half has been flipped over. So that's our cubic function. And then our cube root function, the inverse, looks like this. So imagine you swapped all of the x and y values. This is the graph that you would get. So you can see that both x cubed and cube root of x, they both pass the vertical line test, so they are both functions, which again is why we do not need to restrict the domain. All right, so let's give a few of these a try together. So again, we're going to find the inverse, and then we're going to graph them both to confirm our answers. So here we're going to start by swapping x and y. So we say x equals 3 over 2y cubed. So we want to make sure to isolate y cubed. So we can actually multiply both sides by this reciprocal to clear the 3 over 2. So we can actually multiply both sides by 2 over 3. There we go. And we end up with 2 over 3x equals y cubed. And then to get rid of that cube, we take the cube root of both sides. So it's going to be the cube root of 2/3 x equals y, and then that is our inverse function. All right, so now let's look at what these graphs look like to see if our answer is correct. So again, we can use Desmos to graph this, but roughly this was what the graph of f of x looks like, and then this is what f inverse of x looks like. So you can see it is reflected over that line, y equals x, so we know that our answer is correct. All right, let's take a look at part B. So again, here we're going to start by swapping x and y. So we get x equals y minus 4 cubed. So since this minus 4 is trapped inside the parentheses, we do need to start by taking the cube root of each side. So the cube root of x equals y minus 4, and now I can add 4 to both sides. Please notice when I add 4 to both sides, that 4 is outside of my cube root. All right, so that should be our inverse. Let's take a look at these graphs so we could double check. All right, so here's what those graphs look like. So here's our cubic function, and then here's a cube root of x plus 4, so you can see that they are reflected over that line y equals x. All right, let's have a look at part C. So again, our first step is always to swap x and y. And now to solve for y, we can start by subtracting 1 from each side. And then we're going to take the cube root of both sides. So here we're taking the cube root of the entire left side and right side. So our inverse function should be the cube root of x minus 1. So notice the entire thing is inside the cube root. So let's take a look at the graphs to see if our inverse is correct. So our graphs end up looking roughly like this. So here's f of x, here's f inverse of x, and you can see that they are reflected over that line y equals x. So there you have it. All right, here's the last example from today's video, so please pause the video, and then when you're ready, hit play to check your answer. So find the inverse, and then double check by graphing on Desmos. All right, so go ahead and check your work here. So swap x and y. Your first step should be to add 3, and then you take the cube root of both sides, and then you can subtract the 2. So make sure that plus 3 is inside your cube root, and the minus 2 is outside. So really quick, if you want to look at the graphs, this is what your function looks like. F of x is in blue, and then f inverse of x is in red. So you can see that it is reflected over that line, y equals x. All right, so that is all for today's video. Thank you guys for watching.